Wait for the button to officially start. Okay. Good night, everyone. We are here with another episode of Dan Does Data. Tonight, we are looking at Microsoft's Cognitive Toolkit. And you might be thinking, didn't you look at that like a year ago? And it was not quite a year ago that I did, in fact, look at this. But since then, they've released Python bindings and made a number of other updates. And I remember when I tried it then, I wasn't super enthused, and I said, well, if they have Python bindings, I'll give it a shot. So they did that, so it's probably my turn to give it another shot and try it out. I have to reinstall the whole thing because I'm on a new hard drive since then. So we're just going to walk through and check that out. So it's Microsoft Cognitive Toolkit. It's abbreviated CNTK. They have a GitHub page where they store sort of most of the information. If you go to cntk.ai, that'll sort of relink back to the Microsoft page. Or just the GitHub page is probably the easiest thing to see and understand and figure out what's going on. So it is yet another machine learning framework. It works in Linux, they say. And I remember using it there before. Now it's got Python bindings, so it's hopefully sort of on level with TensorFlow or Theano or something like that. If you go to their page, let's see, if you go to the main page, no, not the main page, the GitHub page, I gotta remember how I got to the install. What is CNTK? Blogs, performance, yes, it's super fast. I don't remember how I found the install page. Oh, they have a wiki. If you just search CNTK, you'll come up with their wiki page on GitHub. And you could say, oh, how do you set it up? Of course, it works on Windows, or you can use it on Linux. If you're using Linux, you can use this Docker installation, which will just give you a Docker container, or the script-driven installation, which is like a bash script that I think installs all the crap you need and puts it in a special virtual environment. Or we're going to try out the manual install. And they say manual, really, they give you a binary. You don't have to compile from source. If you want to do that, you can. You can go here and see how to compile something from source. But I'd like to do manual just to see how bad it is, see what it's like, and wish that it was all just easy with pip. That is almost certainly what's going to happen. I'll just wish to like, oh, why can't I just pip install this? Because machine learning libraries have lots of dependencies, and so it's not that simple. So we're going to go into Setup Linux Binary Manual. These restrictions apply to 2.0.beta.4.0. Alright, that's fine. We install the binaries, the prereqs, create a new Python 3.4 environment. I'm not a fan of creating a new Python 3.4 environment, so I'm going to not do that. Also, which version of Python do I have? I have at Python 3.5. So hopefully that doesn't matter. It shouldn't be a big deal. Yeah, I don't want to set up a whole new Python environment just to run this. Some people say it's a virtual environment, it's cheap, and I like to have available all my tools all the time, because I never know what I'm going to need. Alright, you need the prereqs. I'm pretty sure I have a C++ compiler. I'm pretty sure my NVIDIA drivers are up to date. OpenMPI is something I'm not sure that I have installed. MPI is Message Passing Interface. So it lets your computer do parallelism at the CPU level. If you have like a quad-core computer, you sort of have 4 CPUs that can all talk to each other. And the way you can actually do that in C code is to use MPI. That was actually the first form of parallelism I learned back in the day in grad school. It's sort of low level, but it's actually pretty easy to get your head around. There's not a million frameworks built on top of it. It's just, you're like, okay, take this integer or whatever and send it from this program to that CPU. So let's look if we have that though. So I'm running Ubuntu. They say you should use 1.10. So I want to know, what's available in the MPI world? lib OpenMPI 1.10. Hey, what do you know? So that's good. Sudo apt-get install lib OpenMPI 1.10. Yeah, do it. Alright. So because I'm using Ubuntu and life is simple, user local MPI in this example. LT/user local MPI? No. Yeah, I mean, why would you go and you wouldn't want user local MPI? Oh, unless they're going to be like MPI-CC. The actual compiler for it is what you might need. MPI-CC? MPI? Huh. Let's see. What other stuff did we have? Lib. Open MPI bin. High performance message passing library. Open MPI -bin. Already there. Okay. Yeah, I got it right here. That's what I thought. All right. Well, let's suppose that that actually worked. Protobuf. I'm not gonna worry about that later. Yes, we're good on that. Python setup. If you do not have Anaconda, install Anaconda. Python 3.5, and yet they're setting up a Python 3.4 environment. So there's some incongruities here. Again, I don't want to have to install a whole freaking new Python environment just to run this. They probably say install Anaconda because it comes pre-cooked with lots of libraries that you need, like NumPy and Matplotlib and all this other stuff. I don't want to fiddle with that. Yeah, download this and then activate this. If you already have a CNTK Python environment, I don't. In your Anaconda installation, I'm not creating an environment. Look, it's not going to happen. I'm going to install CNTK because they supply a wheel file right here. Oh, but I got to go get my hands on that wheel file. How do I do that? Harumph. That is the question. Download the binary package on the release page. That's what I need. Releases. Linux. Do I have 1-bit SGD? So SGD, stochastic gradient descent, 1 bit. I'm not sure what they mean. So there's like, you can have binary neural networks. Is it that? Enabling 1-bit SGD. 1-bit stochastic gradient is an optional component for Microsoft to improve performance during deep neural network training. You may read more about it in this article. We'll briefly check it out. Deep neural networks, one can, at nearly no loss of accuracy, quantize the gradients aggressively to but 1 bit per value. So either you go this way, you go that way. You go this way, you go that way. Rather than saying, oh, it's SGD, you compute the gradient and you go this much in this direction, or maybe a little more, a little less. No, it's just you go that way or not, that way or not, that way. Interesting. We achieve computation speeds of 20K, 7K frames, yada, yada, yada. Single speedups over single GPU of 3.6 and 6.3. Not bad. Of course, on a server with 8 K20s. Yeah, well. So this lets you do data level parallelism is what they're getting at. So I don't have multiple GPUs at my disposal, so I'm going to choose not to worry about this. That might be something cool if you've got an environment that can handle that. I don't think that's something I'm going to have. Okay. So we were going to check out this GPU version, which you have to go to the HTML site, I guess. Okay. License, NVIDIA CUDA. Oh, these are the things you might need. You need OpenCV? That's weird. cuDNN, yeah, I'm familiar with that. Sure, I accept. I really only wanted your wheel file, pal. It's gonna take 20 minutes to download this garbage? 14, 10 minutes? What is... Oh, man, I just wanted the pip one, like the wheel file. Alright, 6 minutes. 5, that's tolerable. If I'd known it would take this long, I would have downloaded it ahead of time. I apologize, everyone. That's just a little wacky. Ugh. So what we're going to have to do is, apparently inside this tarball is the wheel file. And a wheel file, this WHL thing, is like a binary distribution of some kind of Python package. So that's what we want. This is saying, this is CNTK with this version. It's nominally for Python, C compiled Python, C, and then Python for 3.4, or 3.4M. I forget the M, what that means exactly. And it's made for Linux on an x86 processor with a 64-bit word size. So it's a pretty standard processor. If you don't know what the processor is, it's probably this one. Then don't worry about it. I'm not going to install the brain script bindings. I'm not familiar with brain script at all. I saw CNTK did some stuff with it. we'll find out what that's really about. Yeah, I'm super irritated that I have to download all this garbage. Libzip, zlib, like, these are things that I have. I shouldn't have to download them separately. That's really annoying. Is there... How do I... CNTK wheel file. That's all I want. I just want the wheel. Just give me the wheel file. Inside there, and also produce a package. Also produce a package. Cannot find environment. This is going to be irritating to me. Windows. Pygame is now a wheel file. No. Python package extension for Windows. Yada yada yada. Installing TensorFlow. Problem installing this. Ugh, that's irritating. So this is just part of the like story of machine learning. That is, every machine learning software framework exists on some Jenga tower of dependencies that are always a huge pain to set up. And so you've got to hope that you have a special environment that can run them, or someone else has set it up for you. It is tough. Maybe one day someone will write a interface that will sort of pre-cook a lot of these things in it, and people will use it just because it's easy to use, easy to get your hands on, even if it's not the fastest. But like Theano is not that bad to set up. Even TensorFlow, not that bad. I'm a fan of both of those. TensorFlow does not work with my GPU, as I found out last week. Well, as I found out again last week. Theano does, so that's why I use Theano as my typical backend, and I use Keras as the front end. And again, just pip install makes my life simple. I, in one sense, appreciate that they pre-compile, grab all these things for me, but these links are going to end up changing. It's not going to be the same. You have to pre-package it, so I got to download, what is this, like a gigabyte of garbage? It's also taking forever. Oh no, 700 megs. Taking forever because I'm also trying to stream out the video. And I have to check the video, so I'm sort of like streaming it back in too. So if the stream is terrible right now, I apologize. Blame Microsoft as I run this on a Linux system. Okay. And after we get this, we're going to see what's inside, see if we can steal the wheel file. And then you have to muck around with your Python path anyway? Oh no, that might just be... No, it looks like, yeah. Looks like you got to muck around with your path anyway. It's a little silly. If you built OpenMPI yourself, I did not. Make sure to edit its library. Like, yeah, that shouldn't be a problem. Verify setup. I gotta activate the environment. Oh my goodness. This is ridiculous. Downloads. What is this thing called again? CNTK. Yeah, okay. Tell you what, let's move that from there right to here. And let's just take a look at this. What is in this? I don't have Arc? Jeez, oh man. Alright, fine. We'll just open it. Oh god, it's got precompiled libraries, the .sos. Oh my goodness. Oh my goodness. This is a little more stuff than I wanted to deal with. I just wanted to try your library, man. Wasn't that hard. I should be doing this over here. CNTK. Here we go. /CNTK. /Python? Question mark is what I want. Yes, there's our wheel file. There it is. Check it out. Check it out. Okay. And then I want to install from that specific wheel file. I'm not going to run -upgrade because I'm pretty sure it's going to break lots of things. CNTK /CNTK /Python /CNTK. Oh, nope. Missed a... Just tell you miss one thing, you get burned. CNTK. Python /CNTK. Right? Come on. Do I have one too many layers of CNTK? I don't think I do. I think I have just the right number. 2.0. Jesus. And I lost that again. Alright, fine. Do this. Sudo pip3 install. See how this goes. Not a supported wheel on this platform. Right. That is because that is Python 3.4. If I just copied over and used Python 3.5, stack more layers. Yes, more layers would be beautiful. I just need more layers of CNTK to make this work. Just copy it more locally, and let's move CNTK dash. Jeez, oh man, 2 points. Oh yes, 2 point instead of 2 dash. Gotta love this little. That's not a big deal. That doesn't really matter. CNTK dash 2 dot. And we're going to change this to 5. And we're going to behold the magic. See if this works. I'll change these to 5. Oh, that didn't work. Didn't like that. Oh gosh, because it's like it's really expecting everything to be in those specific places. File not found error. Yeah, I noticed that. No such file or directory, yada 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 yada. You know, one of these days, pal. Except you are right. Oh, too many. No, that's reasonable. There we go. Okay. Let's see what happens. Processing, installing, collected, successfully installed. Look at that. We're gonna see if this actually works in a second here. Also, I hope this works with Python 3. Have not? Yes, it should. It said Python 3.4. We're at 3.5. I'm not too worried about the possible difference. I'm not sourcing a silly little. That's not going to happen. I want it in my main available situation. All right, so they say check out tutorials. So we're on the Python cntk.ai/Python docs. Well, let's check out tutorials. Logistic regression. You know what? Just do the simplest stupid thing you can. This is like a Python notebook kind of thing. Yeah, I understand logistic regression. Here we go. This is the secret sauce we want. We're going to find out how much of this stuff breaks and how much of this stuff is okay. Learn CNTK.py. Boom. Okay. So these things will definitely work. NumPy and sys and OS, that's all normal. Let's just import CNTK. This is sort of like the moment of truth. Will this actually work? Well, yell at, no module name CNTK_py. Swig import helper, and so now we find out if I got really seriously burned by, is it expecting all this other stuff to exist? That doesn't. Python. Well, that's in the wheel file, so I don't know what's in there. Lib. Yeah, there's no way for me to know. Lib SVM binary reader. Interesting. Lib multiverse. Image reader H. That's not stuff I need to see there. Dependencies. libqdnn, like just all this pre-compiled stuff. Ugh. Just seems so silly. Bin. CNTK is just some giant ass binary. Look at this. 200 megs of binary right there. 200 megs. Is CNTK like TensorFlow and Theano? I think so. That's what we're trying to find out. And is there anything that sets it apart? So far, it's a little bit more difficult to install. That is all I can officially say. There's some Swig stuff that it doesn't like here. Swig import helper. So do I have a Swig problem? Is that really the problem? I think that's really the issue. Let's turn on Python debugger and try that again. Ding. Import lib. Up. Import error. Oh. Frozen import lib call with frames removed. Exec module load unlocked. Find loaded unlocked. Oh my gosh. Ugh, so much stuff. Kilo Sierra Alpha says he also has a lot of hard times getting things working. Yes, this is one of the dirty secrets of machine learning, that every software library is a huge pain to get working like you would not believe. If you're a sysadmin, I feel especially bad for you because you're going to have machine learning researchers who want all the latest stuff and it just does not work. That's I've talked to sysadmins and we're sort of like, well, Keras built on top of Theano is sort of the least bad in terms of support and installation. All right, so what went wrong? Well, we ignored a lot of their warnings about how to install things. So there's that. There is that. And let's see if this activate CNTK thing really exists. So in CNTK, there is no activate CNTK. But maybe is that in scripts? No. Is it in CNTK? Is that in bin and I missed it? No, it's not. Here's a question. What is CNTK if I just run it? What happens? Cannot find such file. Yeah, it sounded familiar. So if I have to, I will use their little installer of script-based installer where it makes a little environment for you. I don't want to do that because I want to have access to all my tools and all the things that I like. I just want to have it available. I want CNTK available as a module that I can import and not have to think about. Run the Jupyter notebooks. That's pretty cool. I appreciate that they have that. But it's as though it does not exist here. And like I can't even, maybe you just can't import CNTK proper. No, literally it doesn't like that. Doesn't like it. No, it doesn't like it at all. It does not like it. Let us see. /user lib python 3.5 /dist. No. Dist user local lib, excuse me. Lib python 3.5 /dist packages CNTK. What is in there? That's what I want to know. And why don't I have this underscore CNTK py is another good question. There's clearly this thing, which must have some stuff. Is it in libs? Is that it? God, man, this is precompiled. .so files, like you do. That's what happens. What is this? Staff? That's super strange. Not a fan. Not a fan. Ops. IO. Alright, really I should just search the internet for this. See who else has tried to avoid their good instructions like I have. I'm playing the role of a terrible user here. So we find out what happens. Name time utils. No, that's not. Oh, jeez. There. See if anyone else has had this problem. Try to install it. Get the following error. Yada yada yada. Shared a Python path. So maybe I don't have the Python path set up just right. Alright, I do recall seeing that, and I scoffed at it, and I said, I probably don't need to do that. But maybe you do. So CNTK bin /CNTK /bin, like there's so many CNTKs, layers of CNTK here. Look at this, CNTK, bin CNTK, and I'm in the CNTK directory already. Activate the environment by executing the command specified in the installation script. In our example, it will be a source Yeah, I wanted to do it without having to activate a script to set up my environment in a special way. But I may just give up and try that. So I wanted to have more direct control about what was and was not in my environment. Activate CNTK. Also, I didn't see an activate CNTK script. Installation skip. See previous step. Execute the command specified by the installation script. In our example, it will be. See, I didn't set up an Anaconda environment, is the catch. Because I thought I had everything already. I thought I would have already the things needed by that. So probably it's just a Python path thing. Oh yeah, I see this step 4 business. Activate CNTK environment. I don't have a Python path. That's interesting. That's really interesting. Not that. This lib. Maybe it needs to be in here. It's like trying to diagnose it on the fly is not gonna fly here. Yeah, activate CNTK. If I had such a script, I would try it. I didn't think I needed it. I thought you were just using Anaconda to make this simple. So someone in the chat, Mr. Dennis Hernandez, is trying to offer some helpful advice. Because of the steps I have duly ignored, however, that may not apply. Because I do not think I have installed Conda, and I'm not about to do that on the stream. Conda 3? Yeah. That's fine. Or just Conda? Yeah, I already tried that. Source activate. Yeah. Is this one line here? I don't think so. So I suspect... Where is... Here we go. Could have sworn I had a... Here we go. Okay. Someone on the GitHub page. Binary automatic, binary manual source, yada yada yada. Windows 7 started crashing, yada yada yada. Someone else. They don't support Python 2. Well, I support they're not supporting Python 2. Well. Yeah, so maybe I do need to muck with my path. And that is just something that I need to make sure I do. Of course, that is not where mine is. Mine is in there, proj CNTK / CNTK. I think are there 4 CNTKs? I think there's only 3 CNTKs. I think that's right. I believe that's correct. Which means from this point I need 2 CNTKs and then a bin. Yes, okay. And then perhaps the LD library path, which is your dynamic library path. You should really never have to muck with this. But, you know, things happen. And sometimes you do. So CNTK bin, that needs to be changed to just CNTK. My name is not CNTK, but I'm going to say that more than any other phrase today. Triple CNTK, right? But I need a proj in there, because I store things in proj. Projects that I'm working on. Proj / CNTK / CNTK bin. Dependencies lib. Okay. Just to be paranoid, let me kill that Python session. Make another one. Still same problem. Okay. If you built OpenMPI yourself, make sure to add its library. No, I should have OpenMPI, no problem. Because I installed that with Ubuntu using the standard. Yeah, and I don't have an activate, not that I'm aware of. No, I mean there's README. Things that you should read. This is the same as you other instructions online. Yeah. Haven't even gotten to get the GPU business working. CNTK / include. That's useful. I just searched the internet on this. Just this. This person, did they have the same problem I had? Let's find out. Yeah, they essentially had the same problem. But that's the only place on there. Please share the Python path. The guy never responded. Started crashing. Now it's crashed several times. Might reinstall again. Using the same instructions. I don't think this is the part of the problem here. My MPI. What are the options on here? CNTK is a Docker container. Yeah, you know, we might do that. So I like to do this live to demonstrate how like obvious, easy, or not obvious this is going to be. And yes, I acknowledge that I chose to ignore several of the setup instructions. So I'm not railing against CNTK, just the general difficulty of this process, unless you want to install like whole honkin', unless you want to install these giant other systems to manage the support for you. You can find the overview about all the available installation options for CNTK on this page. I think I just came from that page. All right, tell you what, we will take a look at the script-driven process, because I don't think I want to do the make from source code. This will set up a whole new Python 3 environment for me. Oh boy. Oh boy, oh boy, oh boy. All right, so I have this run the bash installation script. Scripts install. So maybe I downloaded the wrong thing. That's entirely possible too. Would not be the first time I do such a thing. CNTK /scripts /install Linux con.install Linux whatever .yaml. Alright. You're supposed to cd there first? Weak. Depends on you. Okay. See what happens. This looks like a git diff. It's going to install Anaconda, probably take a while. Oh boy. Location of this. And then I will activate my CNTK environment, and then we'll continue on doing this. The manual installation sadly did not work. Yeah, I thought I could get away with just pip installing the wheel, but apparently that doesn't play nice with the... Maybe that doesn't play nice with Swig? I feel like I've encountered that in other Swig-based systems before. I don't normally use Swig when I want to make some sort of compiled library available in Python. I usually stick with C-types, just because that way I sort of have absolute control over what's going on. But I understand if you use Swig, you can sort of use lots of different things. Use Boost too, but Boost inevitably gets into serious problems as well. So this is downloading Anaconda 3. How big is Anaconda? That's a good question. Anaconda, for those who don't know, is sort of a Python distribution that comes with a lot of useful data science tools already. And if this is going to take approximately forever, then we might have to cut the stream short. Anaconda 4.2, they don't say how big it is. 400 megabytes. Oh, no, excuse me, 450 megabytes. So I estimate that'll take about 3 or 4 minutes, given how long it took to download the CNTK before. And of course, this might have things that it wants to download on its own. So we could be waiting a while. So contrast with Theano, which is not trivial. You've got to handle the dependencies yourself, but pretty much as a pip install, which is just nice. It makes it easy to play around and try. And you could say that, oh well, you could just use Docker to do this. You could do that, but I like to have full 100% control over my environment. And I often feel like Docker means I'm letting someone else figure this out, and I admit that I cannot figure this out. Maybe that's a very backwards view, and I should give Docker a closer look. Why so big? Are they including the datasets? I believe it's including all the dependencies for a lot of things. And in Anaconda, particularly, why is it so large? You know what? I'm not 100% sure. They might be including some datasets. But yeah, it's including all the dependencies built in. And it has its own... If you don't have the time or disk space for the entire disk, try Miniconda. Damn it. I should have just did this. Why? Miniconda. Should have done that. Oh, that would have been nice. Yeah, so it's installing SQ Alchemy. It's installing all this matplotlib stuff, zlib, 0mq. Lots of nice stuff. I don't deny. It's just, okay, that finished. It's setting some more environment variables, yada, yada, yada. Using Anaconda Cloud API site. And then, like, Anaconda comes with its own package manager, sort of separate from Python. It just, at a certain level, it starts to feel silly. But part of the Jenga tower of dependencies. That's what it all is. So these are all things that, like, I almost certainly already have somewhere on my computer. Yeah, NumPy, have that. Pigments, pretty sure I've got that. Wheel, I have that. I use Wheel. 6, I use 6 already. Pillow, I already use Pillow. But, you know, I gotta download another copy. SciPy, I definitely use SciPy already. Already have it. But it's got to download its own thing, so it knows exactly where they are, and it has full control over them. I feel like package management was a solved problem. Anaconda even has its own Python, says Kilo, Sierra, Alpha. Yes, that is also true, because it's managing its own environments. I don't want to, like, sit here and just let this finish, but at the same time, I'd like to, like, actually take a look at CNTK. I'm sure these Python bindings are good. Let me just look at them, I guess. Here we go. So this was clearly an IPython notebook that they converted to HTML. So it would just be some regular Python stuff. These don't look familiar. Import SGD, okay, learner maybe is what they use instead of optimizer. Set some classes. They make some random data, that's fine. They have matplotlib, yada yada yada. These are nice pictures. I like these pictures. Very good. Specify creating a linear layer. Okay. You make an input variable, you set the type. This is very much like TensorFlow or Theano. And the linear layer, hang on, times. That's a little awkward to call, but then again, very much like TensorFlow or Theano. And my understanding is CNTK does not claim to be a very different framework. They claim to have better benchmarks to be faster. If you scroll around on their webpage, somewhere they've got like pretty pictures saying we're very fast. This picture. They're saying Theano is this blue stuff. Theano's over here. They say only supports 1 GPU. Yeah, and they're claiming that they're doing very well. There's some of these other ones, TensorFlow and Torch and Caffe. Of course, if I never get another library working, then these numbers are 0. And I'm sure they work very well, but if it takes a lot of specialist support to get these things working, and you're like part of a graduate department with very limited resources, or even a corporate research lab, like that's part of your cost, even if it's all open source available for free. Either you've got to pay to have someone else help you, or you just got to spend a lot of time figuring these things out. Yeah, this looks generally very similar. Mini batch, yeah, it's typical stuff. I like this. I like this overview though, right? This thing goes into detail. It's intermixed text and code. The Jupyter Notebook as documentation I really like, and I think they did a very good job with that. This is good documentation that looks like it explains everything. Like, it defines the functions you're using right here. I don't see a lot of magic. They even generated the data in here. Generate random data sample. If you're at all familiar with NumPy, I think this would be pretty straightforward. So I have to give them a lot of credit. This looks like pretty good documentation. I definitely appreciate that. And that's just like the simplest logistic regression, that IPython notebook. Oh, hey, things happened. Okay, CNTK install complete. So I yacked on for on and off. We're not in manual anymore. We are in this. So I gotta source this hootenanny. Yeah, oh, here we go. Ooh, there we go. There's only 2 layers of CNTK now. Haha. Air, bash, only bash is supported. Ugh, no. Move over here. That's definitely a strike against CNTK. Only supporting bash for this. Maybe that's not your fault. Maybe that's Anaconda's fault. But I'm blaming it on you. CNTK is activated. Okay, fine. Python 3. One of these days, man. One of these days. Okay. Import CNTK. Oh, God. The colors are all different. Oh my gosh. Okay, it imported. It's fine. Everything's fine. This is fine. This is fine. Alright, so that actually wasn't that bad. If you follow the scripted install, it's big, it's bloated, it's 450 megabytes at least to install this Anaconda and everything else. But that was relatively painless. So I give them credit for that. If you're having a hard time with the manual install, things aren't working, that install worked pretty well. And that really only took 5 minutes. Just felt like a long time because it's on the stream. And I no longer even remember where I was looking. This tutorial. Yes, here we go. And machine learning primer. That's okay. So we want to make some data. So let's do that. Also, let's set paste. Yeah, there we go. Is there a... These are all notebooks? They don't just have scripts? It's a little irritating. I would have also liked the straight Python scripts. Hello world logistic regression. That's actually pretty cool. Logistic regression. Da, 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 da. Create data.py. No. Also, I appreciate that it is interactive. Because previously when I looked at CNTK, it was just like, here's the model definition file. Then you click run and you wait for everything to go. And no, I want to specify things interactively like this. So this is good. All right, let's blitz through some of this. We're going to generate some data. They have a seed of 0. Let's change our seed to a different number. Say 42, just hypothetically, randomly chosen number. I'm going to take away some of these spaces because I am just going to run this all like that. Let me turn off auto indent because I'm going to get burned by that real quick. There we go. Yeah, this color scheme is different in Bash, and I don't know why, and it's really throwing me off. That might be the thing that drives me nutty. Okay, so this is just a thing to generate some logistic regression type problem with a certain number of features and a certain number of classes, and the features will be useful for figuring out those classes. So rather than using like MNIST again, you can just generate your own thing. My sample size. Okay, that's fine. So let's take a look at features. So we have 2 features, I believe. Not input dimension. 2. It's this. We have 2 classes. This. And labels. So this is basically our data set. And it's already in one-hot format here. So this is a class 0. That's class 1. That's class 0. This is class 1. For our 32 points. There's only 32 data points. Not very many. But that's okay. Whoa. And in fact, alright, we'll look at our pretty picture here. At least I get matplotlib as part of all this. At least I can still have my Vim over here. They can't take that away from me. Can't. Ugh. I hate having to use show. It's just one more thing to type. That's why I like plot.ion. Is this gonna go? There are not that many features. This should not be that complicated. It should really not be that complicated. Oh, it's doing the matplotlib inline. That's taking forever. I'm really thrown off by these colors. It is just so strange. I had no idea Bash, my IPython, would be so different. Question from Fix86. Do you think these frameworks make ML more accessible to coders that may not have any academic background? Yes, I definitely think they do. If you've had to program, like even a simple neural network before, it's not that hard, it's really not that bad, but it's not something you want to have to do all the time. And it's not something you want to have to optimize all the time. So I think in general, for someone not familiar with it, yes, these kind of software frameworks make it so you can play around and try these things. And I seem to have not gotten my plot. Show me the plot. God. See if that works. It's, again, 32 points. This should not be rocket science. It should not take forever. Come on. Come on. Come on. Any day now. Any day now. This is just matplotlib, but it's just, I don't know, maybe it's this weird anaconda environment. I feel like my matplotlib is not. Oh, God, I lost the whole thing. I tell you. Okay. Reload things again. It's only doing one line at a time. That's gonna tick me off to no end. If I can only do one line at a time here, oh my goodness. Doing all this stuff, it's gonna take forever. You guys aren't gonna like it. I'm not gonna like it. That's seriously irritating. I don't know why that is. Some weird Slimux interaction with Bash. I'm not even gonna do the plotting. No, not even gonna deal with it. Let's just move on. We got like 10 minutes left here. Here we go. Do not ever make a variable named input. Input is a Python reserved word. Why? Why? Like invar. Unless you're dealing with like metals and invar plate is something you need to worry about. Let's call it invar. And so now I have to remember to change it when I get around to it over here. But yes, just don't use it. Don't use input as a variable name. It's like I was helping someone program C once. They made a variable name called type. We spent an hour trying to figure that out. Don't do it. Just don't do it. Don't use reserved keywords as variable names. You're gonna have a bad time. Yeah. My dict. So what is even going on here? Your input variable and your output number of output dimensions. This is your input dimension. You set up your weight parameter, which is parameter. So very similar to Theano or TensorFlow. And it's going to be a matrix of input by output. Because for every input dimension, you need to compute something for every output. So if you were computing one thing on the output side, then you're only going to have one weight for every input feature. But if you're computing two things, well, you need two weights for every input feature. Bias parameter, you need one for every output. And they're just storing these things in a global mydict, I guess. Yeah, over here. And times is going to be a special CNTK CUDA optimized version of the times thing. Okay, that's reasonable. What'd I do? Here we go. Okay. We're going to have two output classes, I believe. This is now called invar. And Z should be some funky object, I'm guessing. Yeah. Because it's the same kind of not problem, but format as other machine learning frameworks. You sort of define the graph structure, but that doesn't run, it doesn't compute anything. You haven't put any data in yet. It's just like writing a function. Yeah, they talk about softmax. We're familiar with all that. Let's do this stuff. Labels, I believe we already have. Labels, yes. We've made our data already. So input label is input variable size of num output classes, and it's a float 32. Oh, so this is just inputting our data for labels, right? And Z is, of course, what our model is computing, and we're going to compare that to the label. So compare our predicted probabilities of the classes to the actual ones. And we'll do cross entropy using softmax, which squishes everything down into a probability. Not so bad, not so bad. Apparently you have to evaluate the error with that. Interesting. So what is classification error? Computes the classification error. Finds the index of the highest value. Oh, okay. So this is just giving you your accuracy metric. That's all. Things just have different names. That's what you got to get used to. All right. Configure the training. And yes, a good learner right now would be like reading this and understanding, but doing that on the stream is not very interesting. It's perfect time for you to pause, read that, and then you'll understand hopefully more than I'm just trying to learn by doing right now. So learning rate, sure. Learning rate schedule. Ooh, what's that? Unit type dot mini batch. Learning rate schedule. Create a learning rate schedule using the same semantics as. Interesting. Okay, that's cool. I'm not familiar with that. Learner is stochastic gradient descent. And this, you're saying these are the things you're allowed to manipulate. I'm almost certain. Parameters. List of network parameters to tune. So these are the things that, yes, that you're letting CNTK change. And trainer is the way to say, hey, fit, do this. Given this graph, this node is our output. This is our loss function, this is our metric function, and this is how you're going to improve. Right, so loss and eval are really just other parts of the graph. So just, hey, use whatever this node is on the graph as our loss. Let's take a quick look at that just to see. Model, yes, the root node of the function. Root, I don't know if root is a word I would use. This is the node that's computing some actual score. Loss is what's computing how wrong you are. Eval function is the accuracy metric. So we haven't put in data yet. That's just eval error is not defined. I guess I never defined this. Okay, and then we should, just in just a second, have an actual training thing here. What is going on? Compute the moving average. Buddy, I just want to train. Run the trainer. Hey, look, just show me how to run the training. Why is it being hidden from me? Trainer.train mini batch. Yes, that is what I want. Jeez, oh man. Should not be that complicated. Should not be that complicated. Yeah, it's just, that should be made like front and center, like this is how you train. Trainer dot, okay, here we go. What are the options? Ooh. Previous mini batch, store, save point, test mini batch, train mini batch. Cool. This is where you can put in stuff. Features, labels, yeah. Input. Invar. I'm saying for this, put in features, yes. Comma, and for label, put in labels, yes. So you put in a dictionary. This is very similar to TensorFlow. Put in a dictionary of your inputs, of your actual values, and of your labeled known good things. True. Okay. That's helpful. Oh, and here he's doing it a bunch of times. Interesting. Print training progress. So what does print training progress have? Eval error, get train loss, get train eval criterion. What about this? Get train loss not defined. Erg. Could have sworn it was. Get train loss. Ah, I never defined this line. Okay. Because I'm a terrible person. There we are. If I could spell. So I don't know how many epochs I ended up training for, but that might be just in these configure training that I did not read. It's a little irritating that that's not 100% obvious from the code. Mini batch size, number of samples to train. That isn't something that I can just set in here. Although we're generating new random samples, but I believe that might be the same. I'm not 100% sure on that. Not 100% sure. Alright, but I don't want training loss. I want... What do I want? I want the other one. I want accuracy. How good is it? There's only 2 classes. Can't get that bad, right? Can't get that bad. Get train eval criterion. Here we go. You say eval error 0.5. Yeah. So, like, is this? I don't know what. Trainer.train mini batch. We are gonna have to wrap up here in a few minutes. Argument outputs device. Maps variables to their input data. Yeah, optimize model parameters using specified arguments, mini batch of the training samples. Yeah, it would be great if there was more useful information here. But I understand a lot of this is pre-generated by Swig, so it's not necessarily obvious how it's going to be used. So I'm not sure what's going on there. I'm sure if I just copy-pasted some of this beautiful stuff, it'd all work fine. Let's do that, you know. Throw caution to the wind. Let's grab this. And this. I'm skipping the spaces because IPython will freak. Yeah, well, it freaked anyway. Because if you try to do this... Oh, it actually worked. Did not think that was going to work. Did not think that would work. Alright, fine. Fine. We'll do this. We'll see how it happens. Yeah. Yeah, not surprised something went wrong with the copy paste. Alright. That is what it is. For better or worse, that was CNTK. I think this is just a good understanding of it. Doing the manual install did not work so well. I thought I had everything that would be needed to make it work, but it turns out there's either some special magic in Anaconda or in the sourcing script that they've set up, maybe because they're using Swig to make it available. I know that's often the case. But following the sort of scripted install that downloads Anaconda and does everything for you, but one should be careful to inspect what magic it's really doing and what bloat you're getting on your system. That was pretty straightforward to do. And then actually exploring CNTK, well, that was pretty familiar, very similar to TensorFlow or Theano in terms of this is a mid-level to high-level Python wrapper for machine learning. You specify your graph. You say this is an input. I'm going to be putting something in this variable. This is a parameter. This is something the model can change. And it's got special keywords for how to like matrix multiply things. And you set whatever your loss is. You set whatever your... If you want to set an accuracy metrics, you can do this just for you, the human, to check it out. You tell it how to optimize, and then you tell it to go. I wasn't super big fan of how this worked out. I feel that TensorFlow and Theano make this a little more clear, or maybe their tutorials are just a little more clear on that. I know CNTK only added Python a little while ago, and I just went through this very quickly, so I don't want to dig at them for that. But it seemed a little less intuitive for me. Given that it's very similar to Theano or TensorFlow, I wouldn't be 100% surprised if higher level wrappers like Keras or something didn't end up also supporting CNTK if it became popular. And if it really is faster, then that might be something to look into. But in my case, Theano works fine, and I have Keras on top of Theano, so I will probably be sticking with that. All right, I think that's all we got for tonight. What is going on next week? I have no idea what I'm going to be looking at next week. I asked last week what people would be interested for having me work on. Most people said applied projects, applied projects. So that means I have to find a new applied project. I might go back to some of the autonomous driving stuff. I have a little bit of data, but not enough to really do anything with. So we'll see what ends up happening with that. So I want to wish everyone a happy Thanksgiving if you're in the U.S. If not, hey, just have yourself a good meal on Thursday. It'll be good. All right. Stay safe in the data mines. Take care. Close out all these. Oh my goodness. So many. So many. Look at all these tabs I have. Anaconda, Miniconda. Should try Miniconda.